Hello, everyone. I'm Tristan Kalos, the co-founder and CEO of Escape, and I'm glad to have you all today for the Escape and Backslash Security webinar on the future of AppSec, so combining SAST and DAST for complete application coverage. I'm glad to be joined today by Amit Bismut. Did I pronounce that all right, Amit?
Yes. Hey, everybody.
Okay. The head of product at Backslash Security. I'm glad to have you with us today, Amit, for this webinar. I'm sure it will be a really great session, and I hope the people watching us today will enjoy this session. The goal of today's presentation and webinar is to cover how security teams can mix DAST and SAST together to create a comprehensive security coverage. What we'll cover today is first a quick introduction on who we are, Amit and myself, and then understanding what is exactly SAST and what it is good at, then understanding what is DAST and what it can be used for, and finally, how combining the two can bring the best value and the best efficiency and return on investment to your AppSec program in your organization. So I'm super excited to cover those topics with everyone today. As I said, I'm Tristan. I'm the co-founder and CEO of Escape. I'm an engineer. I was a researcher in artificial intelligence applied to cybersecurity. I noticed firsthand a company I was working in being hacked through an API. So I built a cybersecurity startup to solve the problem that I experienced. And here I am today. And I'm very pleased to be joined by Amit. Amit, I will let you continue from here.
Hey, so super happy to be here today. My name is Amit. Even before we start with the professional stuff, I'm married, happily married. I'm a father of a 2 years old baby girl who is currently knocking at the door. Professionally, for the last 2 decades, I've been in technical roles, leading product teams. In Backslash Security, I'm leading the product, which is a code security platform dealing with modern issues found in application code. And in my experience, I had different technical roles related to web application firewalls, container security, Kubernetes, and cloud. And funny enough, when I was very young, at 2006, when the internet was super naive, I was dealing with ethical hacking. So I know a very specific vector, attack vector, from the other side of the spectrum.
Okay, so let's start by understanding what is SAST. So the traditional terminology stands for Static Application Security Testing. This is the practice of analyzing application code and finding different patterns that indicate vulnerabilities, for example, SQL injection, post-reversal, and cross-site scripting. While this is the traditional definition, today is 2025, and we no longer need to find patterns in the code that indicate vulnerabilities. We need to understand the application. And when I talk about understanding the application, we need to do more than just finding those patterns. For example, understanding the SBOM, the different packages that the application is invoking. We need to understand the data flow of how those lines of code and how those packages interact with each other. We need to also understand the business logic, whether the code that we're scanning is critical for the business or that's a test file. And in addition, we also have different configurations like infrastructure as code and other configurations for the pipeline and the CI/CD that we can analyze statically and understand the story of the application. So how does it at work? So we start with analyzing the code on the left side, and we connect everything into a single graph that tells the story of the application. That graph includes everything that I've mentioned in the previous slide. From that point, a modern SAST will try to find all the entry points and exit points. And the traditional term for that is source and sinks. Basically, the entry points is whenever a data enters the application, and an exit point is where the data leaves the application, potentially with different vulnerabilities. When we find a data flow that starts at the entry point and exits with the exit point, which is vulnerable, we can really detect a vulnerable, exploitable vulnerability. And that's what differentiates a modern SAST versus a traditional SAST. A modern SAST will also understand the relationship between the pieces of code and everything that the code tells. In addition, in reality, in the code itself, there are different mechanisms that can prevent vulnerabilities, such as security frameworks, and to understand whether a vulnerability is actually exploitable, modern SAST need to also understand those specific security frameworks to understand whether they exist in the data flow for the vulnerability or doesn't. Now that we understand that, let's see what are the different strategies to integrate a SAST in the security software development lifecycle. So starting on the left side, you can see that we can include the SAST scanning on the IDE, basically giving insights to the developers as they write their code in their computer. They can really get insights into the security findings that the SAST would find. And that specific practice is really effective for finding vulnerabilities in the code itself. Traditionally, the industry kind of told a lie that pushing everything left is the most, effective way to address vulnerabilities in the code and security issues in the code. But what we see is that when we analyze the actual data and actual findings, it's not the right reality. So, for example, to prevent secrets, scanning the code from the Git provider is not the effective way. So for that, we need to have the pre-commit hook that basically scan and find the secret before the secret was being pushed into the Git provider, leaving some history of the secret. Moving next to the PR check. Whenever a developer is pushing a commit and wants to merge that code, they have a natural process of reviewing the code for different quality issues and other aspects. And this is a very natural place to implement SAST, basically scanning the new code that enters the application and reviewing it for different security issues. So that would be really effective for code vulnerabilities. And you can see that we have two gates for code vulnerabilities: the IDE check, which allows developers to get the opportunity to fix issues very early. But in the IDE, we can't really block anything. It's mostly to give visibility. And on the PR check, we can actually block things. So that's a more hard gate, where the IDE is a soft gate. Moving next to continuous monitoring. So for specifically packages, vulnerable libraries, the reality is that when developers are entering packages very early in the process, they are in 99% of the cases not vulnerable, meaning that whenever a developer adds a package, they would use a package manager like npm, which will take the most recent version of that package. And in 99% of the cases, this package will even not be vulnerable. So putting a gate to try to block those packages early in the process is just not effective. So for packages, the right process is to continuously monitor the production application, analyzing deeply their code and the packages that they consume, and understand whether they have critical exploitable vulnerabilities. So that's the continuous monitoring part. And you can also detect those packages early. You can even detect them in the IDE. But because those packages only become vulnerable only a year after they are in production, it's not effective. So a traditional SAST would basically scan things in one point in the timeline, and the modern SAST will allow you to get those insights and those integrations into different points in time to be more effective. So with that context, let's see a demo of the Backslash Security platform. So this is Backslash platform. To start with, let's see how we connect to the environment or how we start a scan. So there are multiple options, but the most straightforward one is to add a connector that allows Backslash to scan the code directly from the Git provider. And you can see the different providers, the common providers that you have here. So for example, if we choose GitHub, we get a GitHub application that is a standard application that allows Backslash to get access to the code and analyze the code. And from the moment that a Backslash has the access to the code, it can analyze the data flows, it can analyze all the different aspects that are in the code, and to build that solid graph that allows Backslash to understand which security issue is making the most impact and having the most risk for the organization. And with that, let's give you the highlight of how we do that. So in this view, you can see all the vulnerabilities that we found for a specific application, which are exploitable. In that specific application, we have not just the list of vulnerabilities, and if we want, we can show you that we have those lists of vulnerabilities. You can review the list if you wish, but we also show them and group them by their business logic group. So you can see in this case that for this application, there is a product search, product review, chatbot interaction, and there is a user authentication. And just by looking at that business context, I can understand that if I have any issue on the user authentication, it's much more critical because that's the gate to the kingdom. So clicking next shows us not just in what group it has a vulnerability, it shows us the actual flow and show it in a human readable format. And that's because we analyze the code and also implement LLM, AI, to bridge the gap between security teams that not necessarily wants to start and read all the code and still understand the context of the security issue. So here we can see that we perform in the application a JOTH token decoding to do the authentication part, and we're using a vulnerable package. Clicking on the package, we can see the actual path proving that there is an entry point leading to the vulnerable package. And we can see the pieces of the lines of code that shows how from the request, which is a dynamic input coming from the user, that data is eventually being passed to the decode method in that specific package. And in the package itself, there is a verification bypass vulnerability, which basically allows to compromise the application authentication. So unlike a traditional SAST, which will just go line by line and find different patterns of vulnerabilities, we can see that with this platform, we can see a data flow, we can understand that the vulnerability is exploitable with a dynamic value from the outside, and we can also understand the business context of that specific vulnerability to first reduce the noise with understanding the triggerability and whether this package is exploitable. And secondly, we can prioritize between those that are exploitable to understand from which business context they belong. Another point to highlight is that in the other group here, the chatbot interaction, we can see multiple flows leading to vulnerable packages with a similar issue like we saw before. And we can see another flow, which is basically getting a username, which is landing on a vulnerable line of code in the first party code. This is sort of an injection here that we have. And the interesting thing is that we don't really care if it's issues on the first party code, like we have here. It's a vulnerable code, SQL injection, or it's a vulnerable package. And modern SAST doesn't really care because code is code. If there is a flow from the user input leading to the vulnerable package or vulnerable line of code, it's a vulnerability which is exploitable and we care about it. So it kind of breaks the boundaries and the silos of SAST and the traditional term for SEA, software composition analysis, because code is code and we can analyze it deeply and understand whether it's vulnerable or not. So that's the highlights for deeply analyzing the code, understanding and breaking the lines between those definitions of SAST and SEA, and understanding what is exploitable in the context of the application. Now that we've seen that, let's see the other side in the spectrum. So that's whenever we monitor the application and we can find very accurately the exploitable vulnerabilities, let's now look at the IDE. So in my computer, I have a cursor, which is, if you're not familiar with it, that's the most recent hyped IDE because it's using AI. And in this example, I have a piece of code and we have Backslash installed as an IDE integration. And you can see that with Backslash, as a developer, I can see all the packages that are vulnerable and I can see their information as if I was scanning them later in the process. Now I can see the findings and the results very early in the process. And I can see different vulnerabilities in the code itself, in the first party code. The interesting thing, or maybe the most important thing, is providing the right recommendation. So for that specific line of code, you can see that we have this panel with all the information from Backslash, and we have the recommendation. So that piece of recommendation is a text that is specific for the line of code that we have here. It is specific for the language, for the frameworks that the customer is using, so that whenever somebody is trying to remediate it, it will have the right recommendation. And when I say somebody, this can be either a human, the developer, and later on it could be the AI. And recently Google announced that 25% of their code is being written by AI. So leveraging the capabilities of this IDE, we also feed it with the text, allowing the AI to fix it with that recommendation. So you can see the avoid using that trust method is also fed here. And when we click on AI fix in chat, we basically trigger the IDE to use the recommendation that we have provided. And now we can basically apply the fix, and we can really be effective in detecting issues early and allowing either a human or an AI to get the right recommendation and to fix the issue so that on the next scan it will pass on the other side. Another point is that if we create a policy to block for a specific type of security issue, we can see the status coming from Backslash even before we push it to the PR and we have a gate that is blocking the vulnerabilities. And that's really giving power to the security teams, allowing them to create a policy and reflect and give visibility to developers very early in the IDE. Because we can't really block in the IDE, but we can give visibility into what is going to be blocked later on the process.
Okay, so first of all, before we dig into how DAST helps with security teams, let's start by understanding what DAST is and how it works. So DAST stands for Dynamic Application Security Testing. It is a security testing method that analyzes and running application to identify vulnerabilities. So it simulates how an attacker might exploit applications from the outside. If we take a very simple schema to explain how DAST works, it simulates attack on a live application like an attacker would do, for instance, by sending HTTP payloads to a running application, and after the scan, it outputs security issues and explains how the issues were found. Now, this is how basic DAST works. Legacy DAST or basic DAST has advantages. It is very easy to scale and deploy because you just have to point it at an application and it will scan it and it will find issues that are directly exposed, so that are probably directly exploitable by attackers or by malicious users. On the other hand, legacy DAST have had a lot of limitations that even impacted the reputation of DAST as a security tool. It is far from the developers, and it is hard to integrate in the CI/CD, which doesn't match with the modern shift-left practices. it is unable to test APIs properly, and today 80% of the global web traffic comes from APIs. So we have a problem of compatibility with the modern development practices. And it is unable to test the applications at the business logic level. And today, most of the web applications that we use are actually very heavy on business logic. There are full-scale apps that are actually exposed in a web browser, but there are full-scale apps nonetheless. So what is a modern DAST in this context? A modern DAST has the following characteristics. It is easy to implement in the software development lifecycle, and it is actionable for the developers. So the developers can take actions on the findings and streamline the remediation process. A modern DAST has native support for testing APIs, testing microservices, and single-page applications. So all the modern tech stack, all the tools that we use to actually produce modern applications. And finally, a modern DAST is able to test what brings the most value out of DAST, meaning testing applications at the business logic level. And I will take some time to explain that, because testing applications at the business logic level is very hard technically. So modern applications we know are based on APIs and business logic flows. It means that a user will call an API, get some data from the API, and reuse this data in another transaction. It is a graph of requests that had dependencies with each other. Legacy DAST tools are built to test web pages. They don't understand the dependencies between resources, the dependencies between data, and so they're not adapted to test this kind of application that are heavy on business logic. So a modern DAST uses powerful reinforcement learning techniques in order to create a chain of thought to assess the application security automatically, like a human pen tester would do. An example of chain of thought would be, I want to test this specific endpoint in my application. This endpoint requires an ID. I can find a valid ID in this specific API route. So I launch this API route, and now I have a set of valid IDs, and I will keep that in mind for the rest of the test. So modern DAST is smart enough to understand the structure of the application and run very efficient testing that is at the business logic level. So what are the benefits of this approach compared to legacy DAST? So we ran a benchmark at Escape, and we saw almost 4,000% test coverage improvement over legacy DAST. And the link to this benchmark is public, so you can see by yourself. There is a massive improvement in coverage, code coverage of the testing. The time to pen test an application can go from days to minutes, because you just have to launch a scan on an application to have like a full pen test that is run on the business logic of this app. And it can find, in our experience, 80% of the API vulnerabilities specifically earlier in the development process, and help streamlining the fix of those vulnerabilities. Okay, so now how do we implement this modern DAST into the software development lifecycle? From our experience, there are 3 scenarios that different companies adopt to deploy modern DAST in their environment. The first one is continuous monitoring. It is a regular scan of their production environment. All the exposed applications are scanned, for instance, every week or every day, and the results are sent to the developers for remediation. A more shift-left approach can be to scan the staging environment after each release. So the DAST is connected to the Git or to the CI/CD, and every time there is a new version of the code, it rescans the pre-prod environment, perform a test, and helps the developer fix the issues in a continuous way. And the third way to deploy DAST in the CI/CD pipeline is using live preview environments. So if your company has live preview environments, you can actually trigger DAST scans for every single version of the code that every developer is building, and gives them insights in real time. So now the best way for you to integrate DAST will depend on the level of maturity of your development process and how you can integrate it so that it streamlines the process in the best way. Okay, so this was for the presentation of the DAST. I'll run a quick presentation of how it looks like, how a modern DAST can look like in real life with a short escape demo before we get back to SAST. Okay, so here is my screen. I will run a new security scan to show you how easy it is to start a scan with a modern DAST. So it's very simple and scalable to start a scan. I can just go to this button, select an API or application type. We can test REST APIs, GraphQL APIs, or full-scale web applications. I will just enter, oops, this one. I will just enter the URL of my application in order to start scanning it. So in this case, it's a GraphQL app. It works the same for all the application types. And I will click on Start a Scan. And that's all. Only with this configuration, I can start having a full-scale pen test on my application. So, of course, we can go deeper. We can have authenticated scanning. We can give the modern DAST more information on this application to perform a more in-depth testing, but we already have a good level of coverage by just entering the application URL. Now, if we take a look at the results, so I'll give you the results on the same application, a scan that ran a few hours ago. You can see that we can track over time the health score of this application, the number of issues, and the performance and the response time. We also have the issues per categories, and if this application is compliant with various security standards like OWASP Top 10, PCI DSS, SOC 2, or NIST 2. Now, if I want to help the developers fix the issues, I can go to the issue, and for every issue, including complex vulnerability issues like BOLAs or EDORs, I will have a description of the problem. I will have a suggestion of how to remediate to this specific issue, and I will have all the necessary information to reproduce the issue, including like the request, the response, the data, the ability to copy it as a curl. So I will have all the necessary information to analyze and reproduce the issue and verify that there is indeed a problem here. Okay, all of these issues are mapped with compliance standards, and they are mapped with the code owners in your organization, so you know exactly who you need to talk to in order to solve this problem. And you also have the possibility to connect your ticketing integrations to help streamline the process with the right code owners or the right teams. Now, once you have this, you can also create your custom test rules on top of the existing ones that are built in order to tailor your testing to your specific organization and to your specific needs. For viewing on the management side, we have the possibility to look at all the applications exposed by your organization and see how compliant they are with different security standards like OWASP Top 10, PCI DSS, ISO 27701, and so on and so forth. And for every single framework, you can see directly a remediation roadmap with a mapping of the security control with your scan results in order to streamline the compliance process.
So now moving to the next section. So now that we've seen both how SAST and how DAST work together, let's understand how they can work together in the same environment, under the same applications, and how they complete each other. So the first point is that when we use both of them, we leverage both a static approach and a dynamic approach. Two different approaches allows us to get a greater coverage of different ranges of issues. And we will cover that in details in a second. And another aspect is that when we use static approach, we can assess any code, if it's APIs, if it's a cloud native application, and even if it's not something which is an application that is a mobile application, not running in the cloud, not connected to the internet, we can analyze it and find issues. And the dynamic approach allows us to find a different range of security issues. And as well, it allows you to find any issues in any interface. If it's APIs, if it's GraphQL, which is not necessarily holding a piece of code which defines it, it's just the GraphQL interface itself, which might be vulnerable. Tristan, any points you want to add here?
No, I think this is a great way to present it. I think there is many vulnerabilities that are way easier to find and fix at the static level, and other vulnerabilities that are easier to find and fix at the dynamic level. And especially DAST tests interface, so what you expose, and static, of course, runs deep into the code. So there is a complementarity here that is very strong, and I'm bullish on both.
Yeah. So looking at it more deeply, we can see that there are specific types of vulnerabilities that are more effectively being found by DAST or SAST. That's the first part that I covered earlier. And if we look specifically at SAST, we can see that it is really specialized in finding exploitable vulnerabilities that have a data flow naturally in the way that they can be exploited. And the way that I think about it, most of the vulnerabilities in the code needs to have a flow to really trigger them, right? So even if it's not SQL injection, if it's, let's say, a denial of service, it still needs to have a payload reaching the part of the application which is vulnerable to leverage this vulnerability, to exploit it. So that's something that modern SAST can really do well with very low false positive, or even without false positive. And if we look at traditional SAST, it also looks very deeply in the code, and it can find issues like hard-coded secrets and anything related to best practices, which is not necessarily something you can find from the interface itself, but you can find it when you deeply analyze the code. On the other side, when we look at DAST, we can see that DAST is really, really good at analyzing the interfaces and finding issues related to the access control, the upper part of the application. And it can also simulate different attacks that touches the entire piece of the application, not just the entry point, but also the other parts of the application, like SQL injection. So both DAST and SAST will be able to detect issues like SQL injection and cross-site scripting, but each one of them is having the ability to specialize in different types of vulnerabilities and to more effectively find those types of vulnerabilities. Tristan, any comments on that part?
Yeah, I think there are a few kind of vulnerabilities that are quite interesting here. So first of all, I'm glad to have this vision of modern DAST, modern SAST. Sorry, from working on this presentation together. It's always great to see what innovation happens in the industry. On the DAST part, apart from access control, BOLAs, and IDORs, we have noticed other kind of security issues that appear in more recent organizations that use Webpack or other JavaScript bundlers, and there is a tendency to compile secrets in the front-end code. We have run a research report on that topic, and this has created a lot of new vulnerabilities that are found by the DAST. So this is the beginning of the conclusion of the webinar. The idea that we wanted to transmit with Amit is that SAST and DAST find different type of issues. There is an overlap, for instance, on XSS or SQLi, or a few type of issues are overlap, but most of them are different. They are designed to test different things and also to help with remediations at different levels. SAST will help with finding phantom packages, with giving you full software builds of materials. So understanding what your developers are building with, what they're using to build your applications and how they're building them. DAST will help you finding shadow assets, finding undocumented APIs, finding what your developers are exposing on the internet or exposing in networks. So the combination of the two is the right approach to understand both how they are building things and where the things are exposed and how they are exposed. And this is how you can have full visibility on the full software development lifecycle and the full process of securing the applications that you build.
I haven't mentioned it, but 2 points. First, a modern platform like Backslash that is analyzing the code is not just analyzing the manifest file to find packages, but also the code itself, the first-party code. We have something we call phantom packages. This is where we find that there is a package which is defined in the code itself, but not in the manifest file. So that's another nice point. Another thing that I wanted to share is that when we think about SAST and DAST, we think about black box and white box. But you shared earlier with me that your solution is actually also looking at code to get different insights. So it's interesting to see that, you know, a modern SAST would not just integrate into one point in the SDLC, it would really change how we think about SAST. And the same thing for DAST. A modern DAST, like you guys have, is not just doing a black box analysis, it also gets insights from the code itself.
Yeah, absolutely. So this is a very good point. What I understand from what you were saying, Amit, is that you have some form of reachability analysis that understands if not only if a package is vulnerable, but goes more fine-grained into, is this package imported into my code? Is it used? Perhaps you reach even at the function level. And because at some point, the goal is not only to detect problems, but also to avoid your developers working on fixes that are not relevant, because there is a huge objective of the security team to also protect the engineering team, protect the relationship with the engineering team, protect the efficiency of the engineering team. And so this is very important to fine-tune the results and be sure that what is sent to engineering for remediation is very relevant and is really a risk.
Yeah, I totally agree. I see so many security teams that, you know, they have bad experience with tools where they're basically developers or do not really trust your process. Yeah. So we're super sensitive in finding things that are accurately, exploitable, and starting with the right things that are real risks and true positives. Okay, so moving next.
I think I just want to add something on what you said. It is true, and I saw at the beginning of this discussion, there was a question about IAST. So IAST is interactive application security testing. It is a form of dynamic testing, but that includes an agent that instruments, that includes an agent to instrument the application and guide the dynamic security testing with information from inside the application at runtime. IAST has been praised for the ability to understand exactly what happens inside of the application during the testing. On the other hand, it's quite hard to set up because you have to install an agent in your app. If you have many different languages, the support is complicated. It also, you need to run the application, you need to understand the code and everything. At Escape, we have a different approach. We have an hybrid DAST that basically reads the code of the application and use this understanding of the code to guide the dynamic testing. So we analyze an application statically, reading the code, and then we can launch very precise tests without the need to install an agent, without the need to modify the application at runtime. It's by understanding the code base. So it's a kind of gray box testing, and it has led to very interesting results. We are really proud of this approach that we find different from what existed before.
Yeah, amazing. This is one of the trends in the last years was being agentless, not running agents. And I really relate because we think about time to value. We really want to have security tools that can give you 100% coverage and can give you time to value, like very quickly getting understanding on the posture. And I think that's one of the reasons why IAST didn't really go very, very, popular or very adopted, because it's really, it involves changing your code, and it involves basically more friction with developers.
Absolutely, absolutely. So if we take a step back and we really try to understand where SAST and DAST are positioned in the software development lifecycle. So obviously, traditional SAST is the first thing that you want to implement. It lives in the IDE, in the CI/CD, so at the code level, very early in the development process. And indeed, it can help streamline remediation, but it can also create a false positive. And modern DAST and especially Backslash approach also correlate this with results in production, so production monitoring, production scanning, as we saw during Amit's demo. So it's really more has more width than what existed before in the SAST world. On the DAST side, traditionally it really intervene in production or pre-production, but not earlier. The modern DAST approaches are pushing for a DAST that is easier to integrate at continuous deployment or continuous integration level. So of course, to run a DAST, you need a live environment. So it's not in the IDE, but as soon as the CI/CD, you can start having DAST scans that run and give developers feedback as early as possible to streamline the remediation process. So I'm going to take this question because I think this is a very interesting question. So this question, in regard to DAST strategy, is it recommended to do a complete DAST scan on the entire application as release occur? Or is it recommended to only perform a DAST scan on the parts of the application that have materially changed? I think this is a very good question. And I have seen a lot of security teams wondering, do we test everything at every deployment? Do we try to focus on the specific routes that have changed or that the developers have touched? The thing is, if you think business logic and you think application as a whole, even a small change on a specific route can generate a BOLA at the application level. The approach that we advise is if you have DAST in CI/CD, try to scope it to what your developers are doing. You don't want a full scan every time your developers are releasing something, but run full scans on your pre-prod or prod environment. Modern DAST scans are very fast. They run in minutes, like 6 minutes. So do not hesitate to run those full scans every time you release a major change, like a new version of your application, because this can really help with finding and assessing the application as a whole. But this is a very interesting topic, and I'm open to hearing the opinions of other security engineers or security professionals that have implemented DAST in a software development lifecycle. Okay. Yeah, I mean.
Yeah, on that, I can add that it's also a good question for analyzing statically. So the common approach when we look at the SDLC, when you integrate SAST into the CI process, you really want to, because you involve friction with the developers and they need to wait for that. So we really want to have a very fast scan. So one of the best way to do that is to do a delta scan. So let's say that you have a feature branch with all the changes that you did. So basically the recommendation is to analyze the changes and to understand how those changes affect the security and whether they have vulnerabilities. That's one reason to make the scan really quick. Another reason is to make sure that we only surface issues that are new, because we don't want to show developers issues that they had already. That's not the right workflow, not in the CI. For that, we have tickets and we have another process. So we would do that for code vulnerabilities and analyzing statically, and less for DAST, or it's a different approach than DAST.
Yeah. So we wanted to pinpoint also a few benefits of having a SAST and a DAST together. And I think that's really important. Apart from the vulnerabilities that are found by SAST and by DAST, which are different, or a lot of them are different, there is also an advantage to combining both. Because SAST vulnerabilities are easier to fix because they are detected earlier in the software development lifecycle. and they can pinpoint the line of code and the developer that created or introduced the vulnerability. On the other hand, DAST is easier to scale because you can launch it on thousands of applications without even knowing who develops them. It understands the context and detects business logic issues that needs a database or the code to be run, and it finds the issues that are directly exposed to your attackers. So the combination of both is really not only a way to detect different vulnerabilities, but also to detect different levels of remediation, from vulnerabilities at scale that are easy to remediate to detecting very precise vulnerabilities that are critical and very exposed to the internet and to your attackers. So that's why they are both very critical components of any application security program, and having both can help understand and secure the whole software development lifecycle.
You know, one highlight I just thought about is that if we think about like the standard traditional tools versus the new modern tools like we guys have, this like SAST tool would one of the saying about SAST is that it has a lot of false positive, and the way that a modern tool would basically do that, a modern SAST, is by doing data flow analysis to really understand how things are flowing as if it is a DAST, like leveraging the fact it has access to the code to try to find flows like a DAST, the dynamic approach, would do. And it's going back again to the approach that you guys are using, where DAST is also looking at the code, is also taking, you know, benefits from the two approach together. And I really like to see that, you know, the security tools that we have today are really different from what we had like a decade ago and a few years ago. And you know, even the name of this webinar, DAST and SAST, I would think about it. We wanted to have these names for people to know what to expect for, but I think that there is a different way to think about those techniques. It's no longer SAST or DAST. It's analyzing application security in different technologies to really find and really leverage what these technologies can find.
Yeah, I definitely agree with that. And I think the acronyms, we have to use the acronyms because unfortunately the security budgets are still, you know, very categorized by very precise, you know, industries or very precise budget lines on type of tools. But really what most younger players in the industry or companies trying to, you know, push the boundaries of what is possible are boundaries breaker. They try to, you know, make something different and push what is possible with the technology of static analysis and dynamic analysis by combining them together. Okay, I think we are reaching the end of the presentation. I see that we have a lot of questions. So we can answer all of that. I'm really glad to see the audience is very engaged today. I mean, we have a lot of questions. Okay, I will start with Amina. I see we have a lot. Okay, let's do that. So how do SAST and DAST tools adapt to evolving or zero-day threats? How does it stay up to date with the latest vulnerabilities and attack vector? I can answer that on Escape side. There is no cheat code for that. We have a research team, and they work every day on finding the new kind of attacks, doing security research. How can we attack this new API? How can we attack this new framework? When everyone started using LLMs in their apps, we did some research on how to test LLMs with DAST, and we implemented that directly in Escape. So every time there is a new technology, a new threat, or a new exploitation of a vulnerability that is exploited, we add a security test inside of Escape, and all our customers can have this test running on their application instantly without doing anything.
The same thing goes on static analysis. So the part of packages is using known vulnerabilities, so it has no really it's not really relevant for 0 days. But analyzing code itself is using different patterns that are vulnerable. So what we do is exactly like you said. We also have a research team that is analyzing different patterns for vulnerabilities, and we once we find them, we run research across open sources. We find whether those patterns are actually exist in the wild, so that we could add them into our engine and basically find whether there are vulnerabilities in similar patterns in our customer base.
Yeah, no, I think that's very relevant. On our side, it's very easy, and I will share my screen one last time before we jump to the next question. In Escape's documentation, we have publicly accessible a list of, and it's continuously updated, right? We have a list of all the security test attack scenarios and vulnerabilities that we can discover out of the box. And this list is public and it is updated all the time. So you can see these numbers grow every week. We add new default security tests and new vulnerabilities that can be discovered. Yeah. Okay. So a question about CI/CD security. How are pipelines analyzed to prevent misconfigurations? And same thing about the CI/CD analysis. How is it calculated, and how is it auto-remediated?
Okay, so I'll take this one.
Yes.
Yeah, so misconfiguration. So I think that static analysis is really good for misconfigurations. There are patterns that are really well defined for misconfigurations. So one obvious option is analyzing infrastructure as code. Maybe the simplest option is like defining an S3 bucket, which is not encrypted or publicly opened. So it's a flag in the configuration that we can easily detect. There are more sophisticated ways of thinking about misconfigurations. For example, one of the things that we found in Backslash is that your NPM, whenever you build your container, you might use many people think about development packages as something which is not important. But what if your configurations is not taking that into consideration? And when you build your code, you don't specify which environment you're using, and in fact, you're taking development packages into production. So this is something that we found very common, and we can find it very easily using static analysis. The part about the severity is also interesting. So there are different. I would say the traditional way of thinking about is that each type of vulnerability has different severity, like SQL injection versus past reversal versus something else. In reality, when we analyzed the last 6 years of vulnerabilities, the known vulnerabilities, you can see that each one of the CWEs, when the security teams at the NVD analyzed it, they gave it very different severities based on the CVSS score. And it really depends not just on the type, but also on many other conditions. For example, it's really different if the SQL is on a post, a put, or a get. And there are more and more ways to look at it. And based on the pattern itself, we define the severity.
There are many questions piling up, so we are going to try to cover them all. So this is this is a question for you, Amit. So let's say there is a code base that doesn't get updated often, and new vulnerability in one of the packages hit this application. What is the journey in Backslash to notify and guide the developers team to this new threat?
Amazing question. So this is the natural workflow of dealing with known vulnerabilities in packages. So what would happen is that a new vulnerability will come out. It will be published. Backslash automatically rescan the code whenever a new code is pushed, or whenever there is a new vulnerability matching the code that exists and is vulnerable. And basically, we have different integrations. A very common way to deal with that is to create a policy in Backslash that would create a notification in different platforms like Teams and Slack. and would create automatically a ticket on the relevant team that is responsible for that piece of code.
Yeah, that's a great answer. A question for me then. Since IDOR are tightly bound to business logic, how do the scanner identify these kind of issues? This is a great question because IDORs and BOLAs are very coupled to the business logic of an application, and knowing who has access to what in an application is not even sometimes clear for the developers or for the product managers. So how can a smart DAST scanner identify BOLAs or IDORs when even the product managers or the developers have trouble understanding sometimes who has access to what? At Escape, we solve this question in two different ways. We have built-in rules that identify the most common problems. For instance, if a public user has access to the PII of many people or many users, we know there is a problem. No public access to an API should give access to many PII from many different users. So we pinpoint a problem. The second approach is through custom rules. So we allow any user, security engineers or developers to create custom rules with a simple YAML language, so simple configuration, to say, for instance, a user can only access his account data. So if a user during a scan is able to access two different accounts, then there is a leak. And this is how, with simple checks, simple rules, we can detect very complex business logic issues at the runtime and during the software development lifecycle. Okay. So SemGrep recently received IA in SAST. What do you think about AI in SAST? Is it useful, or do you think it's still very early and are just buzzwords?
Okay.
That's for you, Amit.
So like I showed in the demo, we also leverage AI and LLM. The way that I think about it is that users have their journey and what they do with whenever they find an issue. So they would usually try to understand whether something is a false positive or a negative. So LLM is really great in that. Beside that, the rule base itself is something that we in Backslash leverage LLM to optimize and really understand and find all the entry points. So it's a very part of the core on how we do SAST in the very core of what we do. And what I showed is that we can really understand the business logic, like the business processes are very tightly coupled into the code itself, and it gives a lot of insights about not just do we have a vulnerability here, is also on which specific parts of the application we have those vulnerabilities. So the way that I think about it, it really allows to create innovation and really understand and prioritize things much better.
Okay, I'm trying to see if we answered all the questions. One, do you think GitHub Advanced Security is a SAST solution?
Yeah, so GitHub Security, I think that as part of them being a provider for code, this is like their main core business. Their approach is to do security statically in a very simple way. So they would have the very basic features, and it will be very easy to deploy them, but they will not have any advanced features. So many, and I will not list them, but they will not fall under the category of advanced security tool for static analysis.
Okay, got it. I think we are running out of time, so this will be the last question, but I'm sure there will be a recap, a summary of this webinar on our blog. Thank you, Amit, for participating into the webinar. It was great to have you. Thank you, Alexandra, as well, for organizing the event. And I hope that you enjoyed this webinar and that you learned interesting things about how to implement security in your software development lifecycle. Thank you, everyone. Have a great day or evening, depending on your time zone, and looking forward to hear news from the community.